Hi, everyone. This is a solution for question 5 on homework set number 5. So in this problem, we're given an increasing load. So it's a downward load on a segment of a member AB, and it has a peak intensity of 12 kilonewtons per meter. We're asked to convert it into a single resultant force and tell me where that force acts. So this is an equivalent systems problem, and I'm going to make a copy of this and put it right here and draw on top of that. So for these equivalent systems problems, especially as you're learning, um, my preference is for you to draw them both and label them both. So we need to create two systems that are statically equivalent, so system 1 and 2, and we need in system 2 one force at a certain distance. I've memorized that the centroid of a triangle is at the third point from the heavy side. So this is my resultant force right there. And its location, I measure from that origin to where the force is. I'm going to call that X bar. So I want to go 2/3 of the way of the 2.4 meters that's given. So the first part of this is really easy. So X bar is equal to 2/3 of 2.4 meters. That looks like 1.6. A little mental math there, but run it through your calculator if you need to do so. So I just divided 24 by 3, 8, move the decimal point, 8 times 2, 1.6. So there is where that force is located for these equivalent systems. They need to have the same tendency to rotate, same tendency to translate. And then the amount of the force, F sub r, I just want to integrate the function. So if I make this 0, so if I go from 0 to L, and I gave this some kind of a function like this that described that, integrate that function with respect to length x. That will tell me how much force it is. And this one I can just do area of a triangle. So base time, 1/2 base times height. So the base of the triangle is 2.4 meters. The height of the triangle is 12 kilonewtons per meter, and divide by 2 because it's a triangle. 2.4 times 6. Just minimize mental math errors here. 2.4 times 6 will get me to 14.4 kilonewtons of force. And that is equal to my resultant force. So R for resultant, F for force is a common way to do that. If you wanted to call it something else like P for point load, that's okay as well. All right, that is it for this one, short and sweet.